Mark comes highly recommended, having given a presentation in Suffolk on management of roadside verges. And I remember from quite a while ago hearing him speak at I think it must have been a Cambridge meeting of some sort. And I was really jealous of some of the kit that Lincolnshire has and wished that Cambridgeshire had something similar in order to improve the management of our roadside verges. So over to you, Mark. Tell us how you do it.
Great. Well, thank you very much, and very happy to join you all today. Again, apologies for the delay and the technical problems. Because these talks are short in duration, and because I didn't want to duplicate anything that Kate has already spoken about, I thought that I should focus strictly on the roadside maintenance we undertake in Lincolnshire, within the Lincolnshire context, for the benefit of Grassland Flora, and also to introduce some of the novel approaches that we've taken to date. So I should start at the outset by painting the picture that we have had a very close partnership with our local highways authority, the Lincolnshire County Council Local Highways Authority, to maintain the condition of some what are now 64 roadside nature reserves, accounting for about 80 kilometres of road length. And we do that by cutting and collecting hay with specialist subcontractors, and we also work with local farmers as well. We have an annual budget of about £25,000 per year to do that, provided by the local authority, and that comes to about £150 per kilometre of verge, although we would need more to maintain optimal management. This is supplemented by Natural England for the maintenance of those verges which are designated as SSI verges, and that's with a conservation and enhancement scheme agreement. So we, generally speaking, cut hay between mid-July and the end of September and follow with a flail in autumn in order to achieve the sorts of results you can see in the photograph there, hopefully. How do we do it? Well, bring in the cavalry. Here is our fleet of single axle pedestrian tractors or pedestrian power units, and you'll see here that they can sport a number of detachable attachments which can be interchanged, cutter bars for cutting hay, flails, and you'll see a younger version of me there sporting the Cave Mountain Press mini baler. Looking at the cutter bar mower in action there, you'll see that it can be fitted with extra wheels to give it extra stability on steep slopes. It generates a long strand cut, which is ideal for baling. The flail, on the other hand, will produce a shorter strand cut, but is more robust. So there'll be less downtime, more uptime. And then once you've cut those cuttings, a belt-driven side delivery power rake can either windrow up the long cuttings in preparation for baling, or it can discharge short strand lengths into the hedgerow base if that's your only disposal option. The full suite of kit, including the mini baler, can be stored and transported on a 14-foot flatbed trailer, which can be stored securely inside an insulated 20-foot marine shipping container, as you can see there. And over the last 10 years or so, we've been able to compare the working rate of this pedestrian suite of equipment against that of compact tractors, and found that, as you can see there, the compact tractor suite of equipment and way of working is about twice as efficient. So we would advocate that effectively a hybrid approach to managing road verges with progressively smaller kit as you get to increasingly less accessible terrain. Ideally use the large-scale farm-scale tractor equipment, provided ground pressure, the effects of ground pressure could be mitigated in the favourable soil conditions, and avoiding running the machine on the verge if possible. But if conditions prove less favourable, then compact tractors and single axle machines can be desirable. With all that in mind, though, it is fair to say that haymaking is expensive, it's labour intensive, it's time consuming, and it's incredibly dependent on the weather. So we ask the question, could we substitute for the ecological role of prehistoric nomadic herds of grazing, belching aurochs, the herbivorous megafauna now consigned to the fossil record? Theoretically, they were keeping our grassland flora in all its abundance and diversity in the past. Could we substitute them with a suction flail biomass harvester? And could we substitute their multi-chambered gurgling stomachs with the reactor vessels of anaerobic digestion facilities, which can produce, of course, combined heat and power, which might go somewhere towards offsetting the cost of operations? There are pros and cons, of course, to this concept of biomass harvesting. The do-nothing scenario may well be that we continue to see, for all the reasons that Kate has listed, the continuing loss of road verge grassland diversity. But on the other hand, if we did start to use biomass harvesting, then there might be the potential benefits of improved ecosystem services, namely pollination and biodiversity. We'd be able to put back into favourable condition a lot of our local wildlife sites on road verges. In addition, local authorities would be better able to deliver their biodiversity duties, and they may even be able to lower their carbon footprint through the production of green energy. But one frequent criticism of bioenergy is that it uses up land that would otherwise be grown for food, affecting food availability and food prices. Of course, if we're working with road verges, we're not impacting the food production system. The 25-year environment plan from DEFRA is hugely ambitious and sets a colossal target of the restoration of habitat across 500,000 hectares of land outside of existing designated nature reserves. But if we look at the verges, the area of road verges across England, then it would be possible to deliver 40% of that target if we were simply to put road verges as a whole back into favourable management for grassland diversity. In addition, with the enactment of the forthcoming Environment Bill, developers will be required by law to deliver a 10% biodiversity net gain as a result of their developments, whether commercial, residential, or infrastructural. So if they can't deliver that biodiversity net gain on site as a part of their development, they need to find a way of offsetting off-site. And this could, again, become a source of revenue for biomass harvested from road verges. There are risks to biomass harvesting, and we need to think about how we might mitigate them. Potential risks would include maybe the damage to invertebrate populations, the removal of seeds and shelter for wildlife. Also, we might create a new market for anaerobic digestion feedstocks, which drives more intensive management of verges. And the local authorities, the public sector, may not have the resources to regulate that activity in the private sector. So how could we mitigate that risk? So we feel in the Wildlife Trust that the first important step would be to establish a clear map of verge quality, i.e. of biodiversity risk and opportunity across each county, each local highways authority area. And by optimizing management for the best of the verges, we'd then be able to set about mainstreaming better management for the rest of the network, which could incorporate rotational management with sanctuary strips. We could also seek to monetize biodiversity through habitat banking, as mentioned with biodiversity net gain. So in Lincolnshire, we address the challenge of mapping roadside quality with citizen science recruiting 250 approximately volunteers. We trained them in field botany with field classes. We then asked them to undertake basic surveys based on indicator species, and across 6 survey seasons, they managed, together with our own staff, to cover 1/3 of Lincolnshire, focused on its chalk and limestone areas, totaling about 3,900 kilometres of road. That led to the designation of 159 new roadside local wildlife sites. That was about 250 kilometres of road, amounting to approximately 100 hectares of area. And that's now on a geographic information system reporting facility for reference when utilities companies need to undertake engineering works on road verges, and to inform conservation management decisions strategically on the ground. On the left-hand side of this slide, you'll see some of the results from the Life on the Verge survey work, and hopefully shining out as a potential north-south connective ecological corridor is the course of Ermine Street, the Roman road which runs north-south through Lincolnshire. And you'll see that that links clusters of interest along the way. Looking over to the right-hand side of this slide, you'll see that that data was incorporated into a biodiversity opportunity mapping study for central Lincolnshire, which now informs strategic conservation decision-making. When we summarise that data set, we found that the gold medal winners, those of SSSI standard, accounted really only for about 1% of the network. Second place, or the silver medal winners, they were about 10% of the network. And then the large majority of third best, but not especially interesting botanically, verges, were about 90% of the network. So this suggested to us that if we didn't use a suction flail on the most valuable verges, used it only very carefully with strictly controlled protocols, perhaps on the second best category of verges, but were a little more relaxed about how biomass harvesting could be undertaken in that 90% of the network, this could inform a business case that could then potentially fund the management of the whole. So we looked at the scientific literature, and a review paper published in 2018 that reviewed 54 studies asked the question, how does road verge vegetation management affect the diversity of vascular plants and invertebrates? And it concluded that species richness of vascular plants increases if roadsides are mown each year rather than not, if they're mown twice rather than once a year, and if the hay is removed after every cut is taken. That echoes what Kate's laid out in her guidance. And sadly, there's not enough data out there at the moment for anything definitively to be said about the impact on invertebrates. Combining this paper and our own reading and experience, our conclusions at the Lincolnshire Wildlife Trust have led us to the conclusion that we're best taking the approach that aims to maintain a regime of linear mosaic management. I'll go on to illustrate that in the next slide. Removing those cuttings, leaving an interval between mows of about 10 to 12 weeks, and avoiding June and July, so that we're cutting on the shoulder season, if you like. We're not using a suction flail on designated verges, and we're trying to incorporate sanctuary strips for structure and for life cycle completion. In addition, we're trying to avoid running machinery along the verges. We're mitigating the risk to ground nesting birds, hedgehogs, small vertebrates by carrying the flail along the back verge. And we found also that there appears to be what we're calling a two-cut sweet spot for both energy recovery and biodiversity delivery, which might be self-regulating. That is to say, you have diminishing returns for the energy returned on the energy you invest when you cut and digest grass cuttings. If you cut them, cut and collect and digest more than twice a year, then it ceases to be worth your while. And that means that perhaps the best business case for energy recovery from biomass from verges would be made with 2 cuts a year, which is the best for biodiversity. This slide tries to show a cross-section of a verge, and it's simply trying to illustrate that the linear mosaic management model is one where there is a decreasing level of disturbance, a decreasing frequency of disturbance of road verge vegetation from the carriageway edge towards the back verge or towards the hedgerow. And this photograph shows the retention of a sanctuary strip as part of the haymaking process. So we were inspired by the first biomass harvesting trials from road verges undertaken by Montgomeryshire Wildlife Trust in 2005. They quantified the amount they could harvest, and they also proved that cuttings taken from verges could be used in anaerobic digestion. However, they did leave an open question concerning the viability of its economics and its logistics. So picking up that baton in 2016, we borrowed this huge orange beast from the Belgians, who bought it from the Dutch, and in partnership with all those organizations you can see listed there, we undertook a series of chemical trials, and we ascertained that the properties of the feedstock that we were collecting was indeed favorable for anaerobic digestion. And we also found that the harvest cost was less than the value we might get for selling it for anaerobic digestion, which was a tantalizing result. It suggested that we might be able to break even, fund ourselves, or even be in profit as a result. Moving on to 2018, and in partnership with those organizations you see there, we built our own. We built our own suction flail biomass harvester for road verges, and we improved its efficiency by developing a novel coupling system, which meant that trailers could be attached and detached to ferry away the cuttings while the cutting and collecting unit continued to work, thereby maximizing its operational time. Over 30 tons a day could be harvested, and a speed of between 3 and 5 kilometers an hour could be sustained. Meanwhile, New Holland was working on a T6 tractor, which can now be powered by biomethane, meaning that potentially in the future, in theory, this artificial or primordial grazing beast can now fuel itself potentially with its own cuttings. The last slide here is the latest chapter in that saga, and funded by European funding. The Grassification project, as it's known, is now being run by Kent Wildlife Trust, who in partnership with the consultancy Earthcare Technical is now working in close cahoots with the Environment Agency. Currently, the EA guidance says that it's not permitted to allow anaerobic digestion residue from roadsides to be spread onto agricultural land and thereby be incorporated into the food chain. So the Environment Agency have requested that Kent Wildlife Trust undertake a more detailed risk assessment and more chemical tests of this biomass. Now, this year, more sampling and more analysis will be undertaken by Kent Wildlife Trust, and in response to the data that will be submitted, the EA will seek to establish further guidance and regulations so that potentially we can open a door to a new way of managing road verge vegetation that might enable conservation on a landscape scale beyond just our roadside nature reserves. I hope you all could see that. Again, apologies for the technical difficulties, but I hope that that was visible and audible to you all.
I've got to unmute myself. Yes, that was great. Thank you, Mark. Well done for overcoming the technical difficulties. And it's much appreciated that you've managed to do that. There are a few chat questions. Pete Stroh asks, what do you do with the hay bales, bearing in mind litter must be a problem?
It certainly is, Peter. Yes. So part of the reservations the Environment Agency have are physical contaminants. So whereas we have analysed polyaromatic hydrocarbons and potentially toxic elements such as heavy metals, litter. We've conducted litter surveys. Litter is an issue. So we're the ongoing work continues to see how this might be eliminated from the biomass harvesting through the timing of litter collections, litter picking before the sward has regrown early in the season, and potentially how litter that accumulates subsequent to that point in time, while the sward is growing before the first biomass take, how that could then be filtered out of the material that's harvested. So there are litter sorting lines in recycling plants. There are mechanical solutions to sorting material when feeding an anaerobic digester. In addition, the engineer, Scott's Precision Manufacturing, that you saw listed there on one of the slides, who designed and built our Lincolnshire biomass harvester, they are currently trialling the novel use of certain surface cultivators, or machines with tines that can glean the litter from the sward in advance of a cut and harvest. So that's being investigated, and there are several ways to tackle it. But of course, the simplest way of all might be to simply survey for a heat map of where litter occurs, where creatures of habit, and we found that slow-moving junctions and interchanges at a distance, a reliable, predictable distance from fast food outlets, by which time you may have ingested your hot dog, your burger, your Kentucky Fried Chicken. That generally tends to be where litter accumulates. Anyway, yes, there are different ways to crack that egg, and we're working on them.
Of course, there are different sorts of litter. I guess certainly in Cambridge, some of the verges get fly tipped, and there was one verge that was sort of one of the equivalents of your roadside nature reserves, where clearly a contractor had driven along fairly slowly, and every 50 meters or so had thrown off some asbestos piping. And that must have taken quite a bit of effort to do it like that. But equally, the asbestos is going to be quite difficult to filter out when it comes to doing something like that.
True. Although you could say that potentially the first few passes could be baled to waste, and there might be, as has been granted for our own trials, temporary licenses where the material can be disposed of in a different way, and then the verge has been brought into condition. There is another environmental fate for this material, and it could be sent to energy from waste facilities for incineration. So if litter levels were too high, for example, to be acceptable into an anaerobic digester, then there is an alternative, and potentially, yes, you could work with a hybrid model and segregate biomass harvests accordingly, and then sile them separately.
Pete Stowe also asks, what do you do with the bales that you take off the verges? Can you use that as green hay or anything like that?
We certainly can, and we have, and also I've supplied them to stock. Yes, on the slower moving, lower traffic, more rural roads, the Cs and unclassifieds, we have been able to deliver mini bales. It is labour intensive, but it is one way of forwarding on this material, especially perhaps to horse owners who might not be as interested in the nutritional value of later season hay when that's taken. So yes, when we're baling hay as part of our roadside nature reserve management, then that can find its way towards farmers as bedding and fodder for stock, or else it could be incinerated, or else it could be burnt as energy from waste.
That looks to be all the questions, Mark. So thank you ever so much for taking the time on a Sunday afternoon.
My pleasure.